Okay, so hopefully we can accomplish something good during this summer. I don't know what the situation of the school or something. But my main theme was to teach you mathematical analysis in a rigorous way. But I thought that might be it is better to use mathematical analysis as a good excuse to explore different fields even in mathematics. What I mean by that, for example, if you want to start mathematical analysis, which is the rigorous way of understanding what we learned in Math 4, mainly differential calculus and integral calculus. Okay, of course we can expand it without any ends probably. But that is called mathematical analysis, a rigorous treatment of what we learned essentially in Math 4, differential calculus and integral calculus. One usually people start and take this set of real numbers and its properties. You know that we have the set of real numbers and we have two operations defined on them, multiplication and addition. And then you have some kind of order between them, which number is smaller than the other one. And there is another very important property of real numbers, which is completeness. It means that if you have the real numbers, there is no hole in it. So if you just take the real axis, yes, and then consider only rational numbers, it will not fill up the whole line. Yeah, intuitively speaking. Yes, for example, square root of 2 is 1 point on the axis, but it is not a rational number. So if you just want to stick to rational numbers, there are lots of holes inside the line. And then we need to another axiom. If we want to be able to do analysis in a proper way, we have to fill up those gaps. Because, for example, if we want to discuss about the notion of limits, which is the cornerstone of the derivatives and integrals, we have to be able to get close to a point, yes, as much as we want. If a point is here and I'm getting close to point and there are a lot of holes in between them, then I'm in trouble. So this is intuitive way of thinking about it. Okay, usually analysis books in mathematics, they take real numbers as granted. But they say that, okay, real numbers, and this is the numbers that we know, and then we know operation of addition, multiplication. Of course, we can immediately describe another axiom, which is called the completeness axiom, and then we consider them as axioms, and then we start the building of mathematical analysis from on top of that. But I was thinking that, okay, I don't know, I don't have any plan for these courses. As far as you are here, probably we can continue even next year or the next year, the year after. I don't know what's going to happen. But I was thinking that, okay, let us have a goal to understand mathematical analysis, but whenever we touch some topic which is interesting, we delve into it and come back again to the main theme. Okay, so that's my idea. So for example, I will not take the set of real numbers as granted. So in mathematical analysis, so in mathematics, everything is a set. So even numbers are sets. So the constructions of numbers comes from set theory. So then you construct natural numbers by the notions of set theory. On top of that, you add, integers and rational numbers, and finally real numbers. So I don't exactly know if it is a good way to do it, but I think it is, yeah, it is good to explore this. So the main theme, I don't know when we will be able to come back to the theme of mathematical analysis finally, but at least I want you to have this in the back of your head, that our main theme is to study mathematical analysis with exploring all alleys and the streets in this mathematical avenue that we're actually trying to understand. So I don't know if you agree with that. So, okay. So if you agree with that, then of course, to be able to talk about real numbers very rigorously, we have to learn set theory first. And of course, set theory is a very vast subject. I will try to touch very important parts of it, at least get a flavor of how it works. And of course, before doing that, if I want to do set theory in a little bit proper way, we need to formalize our logic. Of course, logic is something that's also a different field of study in its own, and that is actually very hard probably. But let us formalize a little bit about mathematical logic. I mean, logic is logic. The phrase mathematical, as we say, is we want to make it systematically. Okay, so to bring mathematics, calculations, and things like that within logic to make sure that we can understand it. Okay, is that okay? Yeah. Okay, so today mathematical logic that we want to talk is not actually a very hard one, but it is an introductory, very introductory and short course. I don't know how long it will take. It depends to you. Okay, so let us see what we want to do. The lesson one that I want to talk about is prepositions and logical connectives. I think when I was teaching you, we went through this. Yes, in mathematical like specialization.
I think that was the year before me.
Oh, okay, okay. Okay, so that's also new for you. Okay, that's good.
Yeah.
Okay.
Alexander Elias did
Yeah.
that, but not me.
Okay, okay, good. So let us try to understand this example a little bit. I have started with these examples. Let us read them, okay? So consider the following. Every Swede is a person. Every person is mortal. And then thus every Swede is mortal. Okay, of course, I think this is coming from Aristotle, but he mentioned every Greek is a person, but because we are in Sweden, might be this is more appropriate, yes? And now let us go here and read this phrase. Every Swede is a person, every Turk is a person, thus every Swede is a Turk. Okay? And let us read this one. 3, every lion is male, every male animal is an ant, thus every lion is an ant. Okay? So logic is a systematic way of reasoning. It has that the reason that I brought this example because I want you to understand logic itself is not capable of seeking the truth. Okay, so logic is actually connecting the truth of one statement to the truth of the other statement, truth or falsity. Okay, so if I go back to this example, okay, so here, oh sorry, here, every Swede is a person, which seems to be correct. Every person is mortal. Yeah, that the first one is definitely correct. The second one is probably correct, and thus it depends what is your ontology. Yes, but then thus every Swede is mortal. Okay, so is it logical to you or not? It seems logical. Yes. The second one, every Swede is a person, still true. Every Turk is a person, still true. Thus, every Swede is a Turk, which seems nonsense, even though the first two statements is still true. But let us go to the third one. The third one is completely nonsense. I mean, every lion is male, which is definitely false. Every male animal is an ant, again false. Thus, every lion is an ant. Yeah, it's also false. But the last one seems logical. Yes? And that is what I'm trying to say. All of the statements and phrases in the last one are nonsense, but it is logically correct. It means that if you grant me the truth of this statement that every lion is a male, and you also grant me that every male animal is an ant, I'm not discussing about it. That logic is not capable of discussing the truth of statements. But if you grant me these two, it is logical for me to conclude that every lion is an ant. All of them nonsense. But I just want you to understand, for logic, you don't evaluate the truth of or falsity of statements. You want to see if the connections are correct. Yes? Is that understandable? Okay. So from this perspective, only number 1 and number 3 are logically sound. The second one, even though two of the statements, and you see, number 3, all the statements are nonsense. But at least number 2, the first two statements are true, but the third statement is nonsense. At least it seems that number 3 shouldn't be logical either, but it is logical. That's what I'm trying to make you understand. Is that okay? And then I want to say that, for example, this is also good because I want to make it more systematic. So consider the following exam sentence. I'm going to study. I cannot try to read it without a human tone in it, but let me try to read it as is it possible. I'm going to study math and physics or chemistry. Still, I have my human tone in it, okay? But how do you interpret that? I mean, by putting commas, might be you can change the meaning of the sentence a little bit, yes?
Well, either it would be I'm gonna study both math and physics, or I'm just gonna study chemistry, or it's I'm gonna study math and then either physics or chemistry.
Yeah, something like that. And of course, as humans, we can play around with this by changing our tone, you know? But in logic, we have to be very precise. That's exactly important because at the end of the day, we want to find a connection between logic and computers, as computer science. So might be we need because there is no tone. I don't know in the future might be ChatGPT be able to do that for us. But anyway, when you write a code, then hopefully you have to respect the syntaxes exactly so that the computer understands what you mean. Yes. So if I go back here, for example, I can say I'm going to study math and physics, comma, or chemistry. So then if I put comma here after physics, what is your understanding then? Yes?
Like you're gonna either choose to study math and physics or just chemistry.
Yes, it means that if either I study chemistry or I study math and physics together, if I put comma there, okay? But if I put the comma after this math, what will happen? I'm going to study math and physics or chemistry. So it means definitely I will study math, but among the subjects of physics or chemistry, I have to choose one. Okay. So I mean, these kind of things makes it a little bit important to actually talk about these things in a little bit more formal way. Yes. Any questions? Okay, so let us go to the next one. This is the important thing I want you to know it by heart. So the first thing I want to define is the notion of preposition or statement. Yes, but I will stick to the word preposition as much as I can. Sometimes I forget I use the word statement, but both of them are correct. So a declarative sentence, it's very important that the sentence is declarative, that is either true denoted by T or false denoted by F, but not both, is called a preposition or a statement. The truth or falsity of a preposition is called its truth value, even though F and T, technically speaking, are letters, they are not numbers to say value, but this is common. Because some books, for true, they put 1, borrow it from computer science, and for false, they put 0. So this is common that we talk about a truth value. Okay. So let us give this is clear. I'm saying that it is either true or false, but it doesn't mean it is decisive. You might not be able to decide about the truth value at the moment, but you know the nature of the statement is in a way, the nature of the declarative sentence is a way that you can do that. By the way, I will put this PDF file below the video description on YouTube, but I will put it on Dr. Bobak, not the Arena Academy. Okay. Okay, so let us go to some examples. Yeah. Determine whether each given sentence is a preposition or not. If so, discuss its truth value. Okay. 5 is greater than 2. Is it a state? Is it a preposition? Yes. Why? Because first of all, it's a declarative sentence. Okay. And it is either true or false, which in this case is true. Yes. The other one, 23,777, 23,777 is a prime number. Of course, it is not an extremely hard problem. You can probably understand if it is true or false. But I just want you to understand, for saying it is a preposition in the first place, you don't need to check it right now. You know definitely it is a preposition. But at the moment, you might not be able to immediately decide if it is a prime number or not. Okay, so I would say that for our purpose in this class, because we don't have time, we definitely know that this is a preposition, But at the moment, we are not interested in deciding the truth value of that. Yes? But we know that in the future, if I sit down and check it out, either it is true or false. Okay, the third one, n is a prime number. Okay, is this a proposition?
No.
No, because it doesn't matter how much I weight or how much I calculate, because I don't know the value of n. I will not be able to say if it's a preposition or not, because there is no way for me to assign it. Okay, so but be careful. N is a prime number is still an assertion. It is a declarative sentence, but it is not a preposition. Okay, number 4. Is 7 a prime number? Is this sentence a preposition? No, because it's asking a question. It's not a declarative sentence. Okay, factorize 28 into a product of prime factors. What about this one? No. This is in grammar, we say it's imperative sentence, or I don't remember exactly, but I think it's imperative. It's asking you do something, okay? So that's not a preposition. The weather is warm. Okay. So what is your opinion about this? It's a declarative sentence, but is it definitely true or false? It's subjective a little bit. So let us try. I mean, some textbooks to teach you something about logic, they use these sentences. But let us avoid them, because for people in Sweden, might be 30 degrees is actually warm, but if you're living in equator, probably 30 degrees is a cool summer day. Yes? Okay, so let us avoid these kinds of sentences. So number 7, Paris is the capital of Sweden. Yeah, I would say it's a proposition, and in this case, it is true.
That's false.
Oh, it's false, yes. My geography is awful, okay. It's false. And the last one, every even integer greater than 2 is the sum of 2 primes.
It's a conjecture.
Yeah, but is it a preposition or not?
Yes.
It's a preposition, it's claiming something, it's declaring something, but the problem is that the truth of it is not even known to the greatest mathematician yet. That's a Goldbach conjecture. So apparently it seems to be right, but there is no proof for it yet. So we call it conjecture. I think some related problem is the ternary Goldbach theorem, which has been proven by I don't remember the name, but he claimed that every integer greater than 5 can be written as the sum of 3. No, every odd integer greater than 5 can be written as the sum of 3 primes. If I remember correctly, this has been proven. Yes, but this one is still not being proved yet. But anyway, is it a preposition?
But not the prime numbers, right?
What?
Every integer that are greater than 5 are odd, but not the prime numbers themselves.
The prime numbers as well.
Yeah, that's prime numbers as well. I think so.
They're just products, and not product, sums, not products.
Sums.
Yeah, sums. Yeah. Okay. Yeah. So that is the notion of the preposition. Hopefully, is clear, isn't it?
Yeah.
Okay. Now, of course, one thing that I want to mention here, for example, the first one, I will call it an atomic preposition, because that's a very, I mean, I cannot drop any other thing to keep it still a preposition. I mean, if I drop 5 or is or greater than or 2 or something like that, it is not any preposition. It's not a preposition anymore. So it is not a compound preposition. But of course, in everyday language, we are actually connecting different prepositions in one longer sentence. Yes, when we talk. Yes. So we want to talk about how we can combine these prepositions. Okay, so we have logical connectives. The logical connectives are this. Yes, and then I have this, and I have that, and I have this, and I will have this. Okay, so these are the symbols for logical connectives. So this is called not, this is called and, this is called or, this is called if then, this is called if and only if, This is the symbol. And in mathematics books, usually they abbreviate it with two F's. It's not a misprint. It means if and only if. But of course, the names. This is called negation. This one is called. Let me write it below. Conjunction. This operation is called. This is called disjunction. Okay, so this and that. This one is called conditional. And this one is called biconditional. Yes? If you have any questions, please interrupt. These are just names. Okay, so let me go to here. So, as an example, consider the following prepositions. Let me write them here. By the way, prepositions are usually, I mean, different books have different standards. So, mostly the books are denoting prepositions by capital Latin letters. Of course, if you just use the lowercase letters, it's not a big problem. Okay, so let me write these sentences here, or these prepositions here. So preposition P2 is prime. Forget about if this is true or false. These are just statements, okay? So prepositions. Q, and then I have 2 is rational. And then I have R. R is 2 is the square of an integer. And then last one S, 2 is an integer. Okay? Okay, so translate from English to formal logic and from formal logic to English accordingly. Okay, just a very simple exercise. If you're comfortable with that, we can skip that, but let us try to see some of them. Okay, how do you write the first one? 2 is a prime integer. 2 is prime integer. I mean, I forgot to write a prime integer. So 2 is a prime integer. How do you write it? An integer. So that's the meaning. So we don't even see the word and, but I want you to understand how you translate between English and logic. But when I say 2, P itself is an atomic preposition. It's not compound preposition, yes? 2 is a prime. And then 2 is an integer. Okay? So when I say 2 is a prime integer, so it means that it has both properties simultaneously. So if I want to write the first one in the language of logic, what do I write? Do you agree with me? I write P, and then I want to use the connective and then I use S. So P and S. Yes, so that is what you write for the first one. For the second one, okay, can you write this for me? 2 is rational exactly when 2 is the square of an integer. I'm actually relying a little bit about your knowledge from my teachings to you, and of course a little bit of set theory, even though it is a little bit circular, but I want to take your knowledge from Math 5 in set theory for granted, which is called baby set theory. But I will come back and try to fix it. So if I want to know this, 2 is rational exactly when 2 is the square of an integer. Yes?
Or if then Q.
So, can you just write it again?
So, or if then Q, right?
If that means arrow.
No, it's, yes, exactly.
Yeah. Then Q. So let us read. 2 is the square of an integer. Then, what? 2 is rational. Is that right? Yes? Yes or no?
Yes.
Okay, so if I took the word exactly out, what do you write then? So let me go back here.
Should it be if only?
Let us go back here. So 2 is rational exactly when 2 is the square of an integer. Yes. So what you told me is if R, then Q.
Yeah.
So do you think that this word exactly doesn't play any role in this text? So I mean, let us take that I take this exactly out.
I think you could,
What do you write then? Do you write still the same?
No.
because I would say that if the word was only when, because I don't think exactly is really the same as only.
Yeah, I mean, I want you to rely on your English. I mean, English is not my native language either, but I might have made a little bit of mistake. But I think the word exactly means
If exactly is only in this case, then would be if and only.
if and only if. I would say that when you see the word exactly, you need to understand it's if and only if. Okay, so I would prefer to write if and only if here. Yes, yeah, because it means that 2 is rational when 2 is the square of an integer. And if 2 is the square of an integer, then it is rational because it says that this phenomenon, if you can call it, occurs exactly when the other phenomenon occurs. So it means that they are equivalent somehow. Yes.
So you could like also replace exactly with only.
Only, yes. I intentionally choose the word exactly because if I write only, you immediately understand what was my purpose. Yeah, I just wanted to give a twist to it, okay? Okay, and then let us go that here. So, for example, I just try to say that you don't see the word if and only if, because if I write 2 is rational if and only if 2 is the square of an integer, it is not hard to translate it. My goal is to be able to understand a little bit how we should translate English or your own language into mathematical logic. Okay, so if I go next to the third one, 2 is prime but not an integer. Yes, 2 is prime. Okay. But not an integer. So if I want to write number 3, what should I write? So P is 2 is an integer, so definitely P is involved. It is not an integer. S is an integer, but I want negation, not. So not S should also be involved. And then let us, for the time being, I do not have any conventions about using brackets, so let me for the time being use the brackets. And then what should I put in between?
And.
Yes, but you don't see the phrase and in the sentence. So what is playing the role of and here? But. Okay, so I would say and. Is that understandable? So this is also the translation. For example, I don't know, might be I can say that 2 is prime although it is not an integer. Something like that. Again, this means and. Yes, is that understandable? Okay. So now let us go to the other one. Okay, I have written, although 2 is not prime, it is rational. So how do you write this? Although 2 is not prime, negation of P and Q. Something like that. Okay. Okay, the next one, 2 is the square of an integer, and if 2 is an integer, then 2 is prime. 2 is the square, okay, so 2 is the square of an integer. So what does it mean? R, and, so it is clear. And what? And what? So what was that? This one. And if 2 is an integer, then 2 is prime. And, so I put and. If 2 is an integer, then it is prime. So what should I write? It is an integer. Yes?
Should you use brackets?
Yes, yes. And then it is prime. Yes? Something like
Wait, shouldn't brackets be between R and S?
No.
Or am I
Because
Or
because it's not if both. It's a square of an integer.
I would have read it like that, but
no, 2 is the square of an integer.
No, because I mean, how do you read it like that? You mean you read it as 2 is the integer of 2 is the square of an integer, and if, because of if, we cannot read it what you say. Yeah, yeah, there is an if there. Yes, you are right. I mean, you are right. Okay, but there is an if there. Okay, number 6. 2 is rational when 2 is the square of an integer, and that is I have taken out the word exactly. Okay, something like that. So 2 is rational when 2 is the square of an integer.
So then it would be R then Q.
Okay, so
When
it means that if 2 is the square of an integer, then 2 is rational. Yes, even though it has written in the other way around in the English language. Yes, so which one implies the other one? 2 is the square of an integer, is r, then what?
Q.
What was that? Q, yes.
R then Q.
So this, if I want to read it, it becomes 2 is the square of an integer. If 2 is the square of an integer, then 2 is rational. Okay, so that's exactly that sentence. Okay, if I go back here, either 2 is prime and 2 is an integer, or 2 is rational. So here comma plays an important role, okay? So either 2 is prime and 2 is an integer,
Yours is
yes,
P and
or 2 is rational.
either
How do you write this down?
P and S
or Q.
brackets or
Yeah, anyone? It's okay. Yes?
P and S. First.
P and S, yes. So P and S.
In brackets.
So let me put in brackets, yes.
Or Q.
Or what?
Q.
Q. Yes. So either in English is waiting for this this junction. Yes, because it is coming in the first, but it is still waiting for this junction. Okay. So yeah, please double check because I cannot go back and forth. Are you sure that? Because we are publishing the video as well, so make sure that we are not making any mistakes. Okay. Are you okay with what I have written?
yes.
Okay. So number 8, 2 is prime and either 2 is an integer or 2 is rational. 2 is prime is what? Which one? 2 is prime is P. And then you say and either or. Yes? Either or, which one of them? 2 is an integer, 2 is rational. 2 is an integer, yes? 2 is an integer is S. 2 is a rational is Q. Am I right?
Yeah.
Okay. Okay, let us do the other way around. So P or Q, how do you read it? I mean, you can read it in any way you like. Yes, P or Q. You can say 2 is prime,
Either
or okay, either 2 is prime or 2 is rational, something like that. Okay, can you even read this one? I mean, reading this is easy because writing it in plain English is a little bit problematic if you want to. But how do you understand that?
If 2 is rational, either 2 is not a prime or.
Not either, because after implication you see and.
Oh, no, it's and. So,
Yes.
If 2 is rational.
If 2 is rational,
Yeah, 2 is not a prime, and
then
2 is not a prime, and 2 is the square root of an integer.
yes, something like that. Okay, or in English you can say that 2 is rational implies that, yes, neither 2 is a prime number nor 2 is a square of an integer. Yes, it's not a very interesting exercise, but I want you to understand how is it going. Yes, please.
Yeah, or like generally it's not exclusive.
Yes, I will talk about that. When I'm just coming back to the tables, I will say that in mathematics, or is always exclusive.
And then if you like phrase the sentence as either x or y,
Yeah.
that to me feels like you say that it's an exclusive or.
Yes, yeah, something like that. So that's what exactly. That's why I'm trying to say that. For me, seeing the formulas is the best way to interpret.
Oh wait, sorry. Did you say that we saw or as an exclusive or
No, inclusive.
inclusive? Yeah.
Yes. I made a mistake. In mathematics, or is inclusive always.
Yes.
Yes. So I will discuss about this in a short while. Okay. So is that understandable now? Yes.
Can I answer it?
Yes, you want to answer? Yes. Which one?
12. Did they go through that?
No, I didn't want to go through it.
Ah,
If you want, because I